Okay, today's lecture is on analysis of 3D frame using flexibility method. Actually, this lecture is very important because it fulfills the main course objective, that is to solve 3D systems at an advanced level, at MSc level. We have to solve or deal with 3D structures. In previous lectures, we solved 2D beam and frame, 2D frame, yes, using this flexibility method. So let's start. Okay, this is a space frame and it has got 3 supports. We have to find first its SI. So SI should be measured using this formula, 6m plus r minus 6j. You have got 3 members, 1, 2 and 3, and we have got 12 support reactions because this vertical, this in x direction, this in z. Similarly, here we have y, we have z, and we have x. At fixed support, in addition to this 3 reactions, we have got 3 moments as well. So this moment is in x direction, this moment is in z direction, and this moment is in y direction. So we have 12 reactions. We have 4 joints, 1 joint, we have 2 joints, and we have got 3 joints, and we have 1 central joint. So we have 4 joints. So measuring SI using this formula, we get 6 degrees. It means in order to make it determinate, we have to remove 6 reactions. So you can remove 6 reactions either by removing these 2 supports, because each support has got 3 reactions, or you can remove this fixed support. But I will not recommend the second case, that is removing the fixed support, because if you remove the fixed support from a frame, then no support would be able to take moments. So structure or frame would not remain stable. So best strategy is to remove the hinge support, and this fixed support should always remain there because it is essential for the stability of frame, because it can take vertical reaction, it can take reactions in XYZ, and it can take moments in XYZ. So in order to make it determinate, or to make a basic determinate structure, I will remove these 2 hinge lip supports, this one and this one. Okay, I have removed these supports and I have got 6 reactions, this AR1, AR2, AR3, AR4, AR5, because each support has 3 reactions. This is the reference frame, this is X, Y and Z. Okay, next I have to construct the flexibility method, and I have to apply reactions one by one. I have to apply the redundant actions one by one, and I'll have to construct a moment table. Okay, first I'll apply this AR1 is equal to 1. This AR1 is equal to 1 cape, and I'll construct this table. Okay, in this table you can see MX, MY, MZ. These are the 3 moments in MX, MY and MZ, and this is TX, TY and TZ. These are torsions. Okay, for example, we have a member and it is in X direction, and this is a moment. Now this is the moment because it is at 90 degrees with this member. This member is in X and this moment is in Y. So okay, it's a moment. But what if we have a moment like this? You can see that this moment is along X and this member is also along X. It means it is a torsion and not a moment. So it will come under this category, TX, TY or TZ. Okay, first we have to, we applied 1 cape and it has to be balanced here. So I have balanced it using 1 cape downwards. It is in Y and this member is in Y. So as a result, no moment would be formed because Y-Y combination gives us no moment. Okay, this O joint is not balanced now. This O joint has to be balanced. This is the O joint. So it can be balanced here. with 1 kip upwards. You cannot apply 1 kip here because there is no support here. So this, if it has to be balanced with this 1 kip, and it would be then balanced by this fixed support. Okay, I have balanced it as well. 1 kip with downward 1 kip. Okay, now this load is in Y direction and this member is in X direction. So Y, loading is in Y, member is in X. So there would be a moment that would be in Z direction. Okay, moving this load towards this support, it forms an anti-clockwise moment. So I'll have to resist it using clockwise moment. So this is a clockwise moment in MZ. You should know that this is an anti-clockwise moment in Y. This is an anti-clockwise moment in Z. And this is an anti-clockwise moment in X using right hand rule. These all are counterclockwise or anti-clockwise. So you should know that this is a clockwise moment. It forms an anti-clockwise moment, so I have balanced it using clockwise moment. Now coming on to this table. Okay, okay, let me remove all these things. Okay, this member is in Y. Okay, I have chosen 3 sections because it can be easily split into 3 sections, that is BO, CO and AO. Okay, it's better or it's best to take origin from supports A, B and C. Okay, first now we have to construct, evaluate or assess the moments in each section. So origin for AO is A, so I'll start from here. This distance would be Y. I have to find all moments here. Okay, now you have to see all the loading below that section, below this string, because the section has been started from it. So all the moments that are being formed here would be taken into account. Okay, this is 1 kip in Y direction, this member is in Y direction, so there would be no moment. As a result, all these boxes are empty. Okay, taking member BO, and your origin will be B and this distance would be Z because this is in Z direction. Okay, this is I mean, it must be confusing you, but this is X, Y and this is Z, but this is a right hand rule. Okay, this is Z direction. We have to find all moments here. Okay, on the right side there is no loading, so there would be no moment here. As a result, all the boxes are empty here. For this section, my origin is C. I have to evaluate all moments here. You can see that this is clockwise in Z direction, so there would be a resistive moment in Z direction. This is counterclockwise. This is counterclockwise. You should know that these all are counter or anti-clockwise. These are CCW. Okay, so this should be minus 20. This is 20. It is balanced here as minus 20. So this is minus 20 here. This 1 kip, move this 1 kip towards this, it will form an anti-clockwise moment. So resistive will be clockwise. 1 into the distance is X, 1 into X. Anti-resistive would be plus X clockwise. In this way I have completed this table. Next, I have to apply in X direction because AR2, this is AR2. Okay, I have applied 1 kip in X direction here, and again, first of all, I'll balance this. So it would be balanced, 1 kip would be balanced here with 1 kip. Okay, this load is in X direction and this is in Y. So there would be, or there should be a moment in Z direction, X, Y. Okay, it is forming a clockwise moment. It is forming a clockwise moment. it is forming a clockwise movement, so there should be a resistive anti-clockwise movement in z direction. This is anti-clockwise. You should know that this is anti-clockwise y, this is anti-clockwise z, this is anti-clockwise x. So 1 into y, this distance is y. Okay, I think y, this sectioning would be taken later. Okay, 1 into 15. So it forms clockwise movement, resistive would be 15 kip foot. Now this 15 kip foot would be balanced here with this 15 kip foot. It cannot be balanced here because there is no support here. So I have balanced this joint, O joint, with 15 kip foot here. And obviously this rightward would be balanced here with 1 kip leftwards. This joint has now balanced, is now balanced. Now I have to balance this member. So this member can be easily balanced. You know that 1 kip is in this direction. So I'll apply 1 kip in rightwards, so it would be balanced. This is in x, this member is in x direction, so there would be no moment. This 15 kip foot would be transferred here because this is clockwise. So I have applied anti-clockwise moment in z direction because this support can take moment. This is a fixed support, so this moment has been transferred as it is. Next I have to construct the moment table. Okay, to construct a moment table, I have taken this section. Okay, let me take another pen. I have to find all moments here. This is in x, this is in y. So what is the magnitude of moment caused by this 1 kip? In member AO, this is member AO. The origin is A. So this forms a clockwise moment, 1 into y. 1 into y. Clockwise. Resistive would be minus y. Anti in z direction. This is actually minus y. This is minus y. Member BO is empty, so there would be no moment here. Member BO is all empty, so there would be no moment. Now coming on to this member, this is my x. I have taken this section x. I have to find all moments here. What on the left side of this tick, or at the end of this section, this 1 kip is in x direction, this section is in x direction, there would be no moment because of this 1 kip. However, this 15 kip foot is anti-clockwise. It should be balanced here. 15 kip foot. Now this would be z, mz, but it should be plus. So here it has come under the section of, under the heading of mz. Also, you know that this 1 kip was forming a moment in z. This moment is in z direction. That's why it has come under the heading of mz. Next, I have applied this AR3 is equal to 1 kip. AR3 is equal to 1 kip. This 1 kip is applied here. It would be balanced here with 1 kip. Okay. This joint O has to be balanced, so it would be balanced here with 1 kip. Then this 1 kip would be balanced here as shown. Again, this is in z direction and this is in y. So there should be a moment in x direction. Okay, you know, moving this load towards this direction, it forms an anti-clockwise moment. So it should be balanced with a clockwise moment. 1 into, and the length of this member is 15. 1 into 15 gives us 15 kip foot, and this is clockwise. You should know that This is anti-clockwise in y. This is anti-clockwise in z. This is anti-clockwise in x. Counter clockwise or anti-clockwise. It means this is clockwise. Okay, I have balanced this 15 kip foot with opposite, equal and opposite moment, 15 kip foot, and this moment would be as it is transferred to the point C, because this support can take this 15 kip foot. Next, I have to construct the moment table. Okay, for the section BO, you know there is no loading here, so BO section is all empty. However, this section AO, this is O point. My section is selected as such, as shown. Okay, this one kip in Z direction and this section is in Y. There should be a moment in X, MX. It is forming an anti-clockwise moment. It should be balanced with clockwise. And the magnitude would be 1Y or Y. 1 into Y gives us 1Y. That's it. Coming on to this section. The section is CO. Length is 20 feet. Origin is C. I have selected a section X. I have to find all moments here, forming here. This is 15 kip foot and this is along the member. Along this member X. It should be balanced with this moment. Equal and opposite. 15 kip foot. You should know that this member is in X direction and this moment is also in X direction, and it is counterclockwise. You should know that all these moments are counterclockwise or anti-clockwise. So this is minus what? Minus 15. But as it is in X direction, this member or section is also in X direction. It means it's a torsion. So Tx is minus 15. Next, I have this 20 kip foot. How it has come here? Because one kip was in X in Z direction. This was in X, and if you move it this load towards the support, it is forming an anti-clockwise moment. So I have applied a clockwise moment because these are all counterclockwise. So if this is a clockwise moment, if this is a counterclockwise moment in Y, then this is a clockwise moment in Y, downwards. Okay, next I have to find this moment would be resisted here with upward, and you know this is counterclockwise, minus 20. This one kip also forms a moment here, and it is anti-clockwise. You have to balance it with a clockwise, 1 into X, so it is plus X. So I have constructed this table. Next I have to apply AR4. Now it is the turn of the second support, because we have dealt with these reactions. Okay, this one kip and this one kip is balanced with this one kip. This one kip can be balanced here, and which is now balanced here. It cannot be balanced here because it has no support. This one kip, okay, this member, this load is in Z, this member is in Z, so there would be no moment here. This moment is in Z direction, this is in X, and if you move it towards this is forming a clockwise moment. So I have to apply an anti-clockwise moment. You should know that this is anti-clock in Y, this is anti-clock in Z, this is anti-clock moment in X. So all these moments are counter or anti-clockwise. Next I have to construct a moment table. So for a moment table, this there is no activity here, so AO should be 0. Also this is in Y. For member BO, this is in Z direction, this member is also in Z direction, so there is no activity here, all the boxes are empty. For this section, my origin is A, this C point, and I have to find all moments here. This upward, or this is actually a counterclockwise moment. It should be balanced here as it is, because it's a pure moment, so it would be balanced like this. So this is anti and this is would be clockwise, plus 20, plus 20. Next, this one cap is in Z direction, this is X, and if you move it towards this tick, it is forming a clockwise. Okay, Z combination, the load is in Z, member is in X, so moment would be in Y, so it will be coming under this MY. Clockwise X, it should be balanced with anti, so minus X. AR5 will be done by you actually, or AR6 I'll do AR6, because AR5 is quite easy. AR5 you have got these two reactions, so I mean it's very easy. I'll do AR6 is equal to 1. So finally I'll apply AR6 is equal to 1 kip. You know AR6 is a vertical load here, so 1 kip is now balanced with this 1 kip. 1 kip is now balanced with this 1 kip. This will be balanced here with 1 kip, because I have to balance this joint O. This 1 kip then would be balanced by this 1 kip. Okay, again you should know that this 1 kip is in Y direction and this member is in Z direction. So if loading is in Y and the member is in Z direction, there would be a moment in X direction. Why? If you move this reaction towards this support, it forms anti-clockwise moment. This is anti-clockwise moment. Let me clear all these things, because I have to reiterate every time, because you are not so good with your directions and you should be practicing a lot with your directions, because these directions are all very important in this course. These are all counterclockwise moments. This is X, this is Z, and this is Y. These are all counterclockwise or anti-clockwise. Okay, 1 kip load is acting in Y direction, member is in Z direction, moment would be in X direction. So moving this 1 kip towards this O, it is forming an anti-clockwise moment. It would be balanced with a clockwise X. This is clockwise in X direction, because this is anti-clockwise. This 30 kip, because the distance is 30 feet, 1 into 30. This 30 kip foot would be balanced here, 30 kip foot, and it would be then taken here, 30 kip foot, as it is. Okay, this load is in Y direction, this member is in X direction, there would be a moment. Load is in Y direction, member is in X direction, so there should be a moment in Z direction. So it forms a moment. Okay, the CO is actually 20 feet. It forms an anti-clockwise moment, 1 into 20. Anti-clockwise, it should be balanced with a clockwise 20 kip foot. If this is counterclockwise, then this is plus clockwise moment. Next I have to construct the moment table. Okay, this member is all empty, no activity here, so we have all zeros here. This is all zeros. However, if you see this section, my origin is from here. I have to find all moments here. This 1 kip is forming anti-clockwise moment here, 1 into Z. Z is the anti-clockwise moment formed here, 1 into Z. It should be balanced with a clockwise moment. Because this member is in y, this load is in y, and this member is in z, so this moment should be under the mx category. So here mx is equal to plus. Finally, I have this section. I have taken this section because this is in x direction. The name of the section would be x. Okay, here this 20 kip foot should be balanced with equal and opposite 20 kip foot. You know that this is clockwise, so this would be anti-clockwise, so this would be minus 20. So mz would be minus 20 here. This again, this 30 kip foot, it should be balanced here with equal and opposite 30 kip foot. But you know that this section is in x direction and this moment is also in the x direction. It means it's a torsion, and this is minus anti-clockwise, so torsion is minus 30. Torsion is along x-axis, so that's why it's minus 30. Finally, this one kip also forms a moment. This is in reaction is in y direction, member is in x direction, so there would be a moment in z. 1 into x anti-clockwise, it would be balanced with clockwise. Clockwise is always like this, plus x. Done. Now I have to construct the flexibility entities or elements of flexibility method. They are very easy to construct. So you have to, in order to construct F11, you should know, one thing should be clear to you, that there are 6 redundant actions. It means the order of flexibility matrix would be 6 into 6. It means there would be 36 terms in the flexibility method, starting from F11, moving up to F16, then there would be F61, and finally we will have F66. So this would be full with 36 terms. Okay, you have to construct the F11. F11 means that this moment table has to be multiplied with itself. It means x minus 20, the formula is m into m divided by EI. And it should be under the limit, because this is 20 feet, so there would be 20. It should be integrated under a limit because you are using the method of sectioning. You cannot use conjugate beam method. Okay, because x minus 20 has to be multiplied with, this would be self-multiplying with itself within this limit. This one, I have multiplied x minus 20 with itself, and we have got this value. Similarly, for F22, F33, F44, F55, F66, all these matrices would be multiplied with itself. I'll explain. I'm going to explain in detail about F33. This is quite important. Okay, F33. If we go back to F33, okay, this is the moment table, and you have to self-multiply it. So you will multiply y with y. Okay, first term would be y with y square, and the limit is 15 feet. Okay, so this would be EI. This should be dy, summation sign. Next, I have to self-multiply x minus 20. So x minus 20 divided by EI. this should be dx, the limit should be 20. Obviously you can put 0 here. Finally I have this torsion minus 15, so I'll multiply minus 15 with itself, so it would be square, and here it would be dx, the limit is 20 and 0, but here it would be divided by, would be divided by 0.8 ei. Instead of ei, you will divide it by ei, because actually it is actually in the formula of torsion, T1 when multiplies with T2, it should be divided by Gj, and Gj is taken as, it can be taken as 0.8 ei. 0.8 ei. So you should be very careful while multiplying the torsions. So when you are going to multiply the torsion section, you will divide it with 0.8 ei. Nowhere, okay, here F66 is also very important. You can see here, if you go on to F66, okay, I think it's easy. You can easily multiply F6 with itself. If I clear all these things from here, and let me select a red pen here. Okay, here we have this. Okay, in order to construct F66, Z would be multiplying with itself, Z square, and you should apply dz here. As it is a simple moment, so it would be ei here, and it would be 30. Okay, using calculator you can easily evaluate it. I mean, you had been doing it, solving these integrals since your FSC, so it's very easy. Next, x minus 20. I'm finding F66. It means AR6 moment table is multiplying with itself. EI. Limit is, okay, this should be dx. Limit should be 20. Finally, this minus 30 has to be multiplied with itself. So minus 30 when multiplies it with itself, it would be minus 30, it would be square, as it is dx, so I'll put dx here, I'll divide it. Okay, limit is 20, but it has to be divided by 0.8 ei. Instead of dividing it by simple ei, you have to divide it by 0.8 ei, because this is a torsion. This is a torsion. Simply, okay, we have evaluated this very easily. Now F12 would be equal to F21. It's so simple. F12 and F21 are equal. Numerically they are equal in magnitude. Similarly, F54 is equal to F54. F26 would be equal to F62. So let me find F12 is equal to F21. So you know that x minus 20 has been multiplied with 15. Okay, going on to F12 means you have to deal with AR1 is equal to 1 and AR2 is equal to 1. Let me clear all these things. Okay, F12, it means AR1 is equal to 1, AR2 is equal to 1. You have to go back. Okay, here it is x minus 20. I have only one term, and this is under MZ, and this is for CO and MZ. Here same CO, under MZ I have 15. It means only term we'll get in F12 would be 15 multiplied by x minus 20 under the limit 20. No other limits, no other things. You can see here F12 x minus 20 has been multiplied with 15. Next, f4 5 and f5 4. So I'll go back to AR1 is equal to 1, AR4 is equal to 1 kip, and AR5 is equal to 1 kip. AR4 and 5. Okay, this one. Let me clear all these things and this as well. AR4 is equal to 1 kip. I have my, and the member is CO, and the moment is my, so I have 20 minus x. So if I have the moment in the same column and in the same row, I can multiply both these values. Otherwise I cannot multiply any other thing. So 20 minus x can be multiplied with 30 because they are both under my and they are for the CO. So you can see 20 minus x would be multiplied with 30 here. So you get this. Finally, I'll multiply these two, f36 and f63, because this would be done by you, this would be done by you, this would be done by you. So, so simple and easy. f36 and f63. Let's find f36 and f63. I have to deal with AR3 is equal to 1 kip and AR6 is equal to 1 kip. AR3, yes. Clear all things. Okay, x minus 20 under my in the third row. I have to deal with third row because no, you have here as well. First, for AO, I have mx. For AR6, I have no mx. It means this would be 0. Because here I have 0, but here I've got the value. The answer would be y into 0 would be 0. Next, B, this would all be 0. Here under my I have x minus 20 for CO, and for torsion I have minus 15. So I have my and I have tx. Here I have no my, but I have a tx. It means minus 30 would be multiplying with minus 50. Minus 30 has been multiplied with minus 50. It should be divided by 0.80i because these are torsions, and you get this value. Finally, all other values are 0. You can find it very easily. For example, let me find f56 and f65. If you are able to find f56, it would be numerically equal to f65. You need not find f65, as I have found here. I have done here. I have found f12, but no need to find f21 because they are numerically equal. I have found f34, but I haven't found f43 because they are numerically equal. So let me find f56 and f65. If I go back, f5, it means in order to find f56, and that would be numerically equal to f65, I have to deal with two moments table. Which moment table? When AR5 was 1 kip and when AR6 was 1 kip. This one. So this is here AR5 is equal to 1 kip. Okay, here let me remove this. Okay, I have under my, I have two moments and both are under my, and one is for BO and one is for CO, and that is Z and minus 30. Here under my I have no moments. It means f56 would be equal to f65 and would be equal to 0 because there is no commonality between these two. Similarly, for f46 and equal to f64, for f13 and f31. Okay, let me go back for F13. I'll clear all these things, erase all things from here. I have to find F13. So F13 would be equal to F31. Okay, for I have to deal with the moment table constructed for this. AR1 is equal to 1k, and it should be multiplied with AR3 equal to 1k. Okay, for FAR1 is equal to 1k under MZ, for section CO, for I have x minus 20. It should be under MZ. It is under MZ, and it's for the section CO. If I come here, I'll find that, okay, this was under MZ and this is for section CO. Here under MZ, for section CO there is no moment. It means here it is 0. So 0 multiplied with x minus 20 gives us 0. It means F13 is equal to F31 would be equal to 0. Okay, I think and then you have to write it in a flexibility method, flexibility matrix. And I want you to do an assignment, and that assignment would be very easy. I know the assignment can be submitted in next week, but you know, how can you find the AR? First you have to multiply, I think, some sort of f minus 1 or minus inverse, yes, and minus DRL. So this f would be written in this f has order 6 cross 6, and this DRL matrix, in order to multiply these two matrices, number of columns here should be equal to number of rows here. The number of columns are here, number of columns are 6 here, so number of rows would be 6 and number of column would be 1. So these both can be multiplied, and it would be done in Excel. You can easily multiply these two matrices. So you have to find AR for this this space frame, but for that you have to construct the DRL matrix. So DRL matrix is your assignment, and you have to construct this. I'll repeat this lecture because this lecture would be repeated for beams and grids, and the concept is same, but you have to try again and again to learn the basic concepts. If you have any problem, please ask me in the comment section, or you can simply mail me, or you can call me as well. Thank you very much.